कैसे भाई? Day 3 of the Leetcode streak. Okay, so today we have question 3720 lexicographically smallest permutation greater than target. लग रहा है इस पूरे वीक lexicographically ही आने वाले हैं. So what the question says, we are given two string s and target both having length n. Okay, return the lexicographically smallest permutation of s that is strictly greater than target. So we have to find like permutations of s and we have to return one permutation that is strictly greater than target, and it should be lexicographically smallest. Like out of all which are greater, the one that is smallest. Okay, so permutation is just like right arrangement, any arrangement. Okay, so this is it. This is the question. Now the first thing, right? The first constraints, right? Sorry. So constraints are like s less than 300. So the length that is less than 300. So constraints are very small. Even if you do brute force, you will be able to solve it. But we are not going to see the brute force approach. The brute force is simple. So then let's understand the problem once. See, you are given s equals to a, b, c, right? What all strings and your target? Target equals to b, b, a. Then what all strings can you form with a, b, c? So let's write a, b, c is one, b, c is another, c, a, b is another. Then you can form one b, a, c, right? You can form one b, what? B, c, a, b already. Is this it? 1, 2, 3, 4. 1, 2, 3, 4, b, a, c. We can form a, c, b as well, right? A, c, b, right? And we can form one C, P, A as well. The total 3 to 3 factorial, right? 6. Okay. Now among these, which are greater than B, P, A? This one is greater, this one is greater, this is not, this is not, this one is greater, this is not. So out of all these three, which one is lexicographically smallest? See BCA, then BC is our answer. So this is what we have to do. Now, when I generated this permutation, we observed one thing. First, what we observed? The order of character does not matter. Order of characters does not matter, right? Now this observation is very important because if you don't get it, that you then you'll not be able to proceed further on this question. The order of character does not matter. That means if I have a bucket of characters, let's say I just assume I have like bunch of characters b, c, a, and I have to format a string. I have to form a string that is greater than b, b, a. Then how am I going to form this? First I'll pick b. See, I know I need a character which is greater than or equals to b. Then I'll from bucket I'll pick b, right? The next is b. Now for the next part I need one that is greater than or equals to b. So which one is this? C. Last is a. And now since C is greater than B, can have anything, right? Why? Because in my prefix there is a character in my answer which is greater than the character at the target position. That means this C, right? This C is greater than B. So if even if I put A or like any smaller character, that will always be greater than. Now this string will always be greater than that. So I'll put anything B, C, A is left, right? So I'll pick it. So that's why first thing we find is we need to prepare this bucket of characters. And how do we prepare this bucket of characters? By counting the frequencies. So we'll prepare the frequency area out of what? S. So this is the first step. Now, after that first step, what we did, see, we greedily pick the character which we can found. That means we match the prefix, right, of target from bucket. See, and why we are doing this? Because of this. We are greedily picking up the characters. So we match the prefix. This is the second part. Now let's do a dry run basically. There is another part to this question, but before I reach to that part, we'll understand a bit more. So let's say your string, right? String equals to s equals to a, b, c, f, c, and your target equals to a, b, c, f, h. This is target. Okay. If you have these two, so one step we have seen first is the we keep a bucket of characters, right? So we'll keep a occurs one time, b occurs one time, c occurs two times, f occurs one time. This is the first, right? Second, we have to match the prefix from target now. Let's match the prefix. In our bucket, do we have A? Yes. So we'll do A, and now count of A decreases by A0, B1, C2, and F1. Okay. Now the second for the second position is T of 0 equals to A. Now second is B, right? And T of 1 equals to B. Do we have B in our bucket? Yes, we have B. So we'll put our B here. So this becomes A0, B0, C2, and F1. Okay. And now, what is the T of 2, right? That is C. Do we have C? So, yes, we have C. So, we are going to put C here. And the next will become A0, B0, C1, F1. Now, what is T of 3? That is F, right? T of 3 is F, then we'll match the F here, right? Do we have F? Yes. So, we'll match the F here. Now, A0, B0, C is left 1, and F is 0 now. And what is T of 4, which is equals to H? Do we have H here? No, right? Since we don't have H, our prefix is matched till, so our prefix, right? It is matched till A, B, C, F. This is till where it is matched. And what is your position? Position equals to 4. So that means till position 4, that is 0, 1, 2, 3, we get our prefix. Now, tell me one thing, if I need a string which is just greater, first greater, so out of this prefix, what I have to do? See, what if I just need greater? See, greedily, think greedily. That means the one thing that we need to do here is with every match from right to left, we try to replace it with any character which is just greater than it. See, if this is A, B, C, F, right? You do from right to left, or you can say it backtracking, right? And what you do? Replace character with just greater. Now, see A, B, C, F. If tell me if A, B, C, and for this F position, if I found a character which is just greater than F, let's say I found some X, then anything after this will be valid, right? Valid. So this is what we have to do. This is it. This is the third part of the question. So what was the third part? Backtrack for prefix from right to left, right? For any position, what we have to do? Find a character which is just greater than current. Find a character just greater than current. And what is the last step? Answer. Answer is this, right? So answer is what? First is prefix. Second is was current character which we found. And what is the last step? See, if we found a character which is greater than current, that means rest of the elements can come in any order, right? So rest in ascending order. Rest in ascending order. So this is it. So now let's see this backtracking part. So did you understand why we did backtracking, right? Backtracking is required because we need just greater than and prefix exactly matches. So for our case, right, we reached to the position equals to 4, right? And what our bucket was? A0, B0, C1, F0. And what is target of 4? Which is equals to F. Correct? Okay. Now for this position, is there any greater available? Is there any greater available? No. So we'll go to T of 3, which is, and if not available, we increase the frequency of F. So that means we increase the frequency of F. We increase the frequency of that. We return back the character. Now come for T of 3, which is C. Now can you find a character which is greater than C in my above bucket? In this bucket. So just greater than C. Can you find? Yes. And what did you find? F. Right. So now if we found F, that means our prefix, right? Our prefix was A, B, C. Correct? A, B. Sorry, what was that again? A, B, C, F. And this position was 4 where we break. So we'll start from 4. 4 was this H. So I did one small mistake in indexing. So this will be H. Did we find anything greater than H? No. This will be F. So we'll find anything greater than F. Is there anything greater than F? No. No. Now the next is we return this back and we come to T of what? T of 2 equals to what? C now. If it's C, is there any just greater than it? Is there just greater than it? Yes. And what it is? F. The same step above when I missed this index. So is there anything that is just greater? We found F. So that means our prefix is now A, B. Current character equals to F. And what are the rest of the characters? See, in our bucket, we are left with A0, B0, C two times. Why C two times? Because we returned the current character. And F we have one times. So rest over what? C, C, F we utilized here. So will it becomes 0 because we have used F here. So your answer will be prefix plus what is current? F plus what is rest of the element? C, C. So this will be your answer. Now, what is the time complexity of this entire approach? Time complexity is frequency can be prepared in of and right. Okay. Now, matching the prefix can also be done in of and. Okay. Now, if we backtrack the prefix, we are also returning back. So that means this can also be done in of and. Now, for any position, find a character just greater than it. For it, we have to run a loop, right, from I equals to current position till 26. And we have to find if frequency of I is greater than 0 or not. So that means this will run in of 26. If once it run in of 26, this is just a again of n approach. Now, you tell me one thing. See, this O of n, this is only happens one time. This does not happen in this entire loop every time. So this will only contribute once. So final time complexity will be O of n into 26. So this is the time complexity. Now, this if you still did not get it, watch it again. And the one most important thing is this thinking this step. Once you understand these four steps, one, two, three, and four, this question itself is very easy. So try to understand why we are having count of frequencies, why we are matching the prefix, because we need just greater than. Why we are backtracking? Because we match the prefix exactly. We did not found a greater element. Now, if we match exactly, that means for rest of the that means for this previous position, there can be an element, there can be a character which is just greater than current, and we can form a less smaller lexicographical string. That is why. So just take this very simple example. I did it wrong in the first try. So S equals to AB. Your target equals to AB. So what is the string that you will form after prefix matching? AB. But AB cannot be your answer, right? So that means now you do backtrack. So after backtrack, you put A equals your B becomes 1 and your prefix remains A. But you don't find anything greater than it. Okay, the next will be you return A as well. A return, B return 1. Now you don't have anything, means you are at the beginning. So you find first position which is greater than A. So A is you found B, after that you can put anything. So your answer becomes BA. So that is why. So you also try to solve it via pen and paper and try to reach to the optimal solution. So this solution will work for like even if n equals to 10 raised to power 5. In our current question, it's 300 only. Okay. So I'll paste the link for the code part in the comment section. If you still need help with the code part, see the Leetcode solution which I posted. And and before that, I suggest you to try to solve it by yourself. Yeah, thank you.